All right. How many of you have ever wondered how Ferrari is able to build such cool cars and also deliver exceptional performance and unmatched power to their demanding customers? And Autodesk, how they've been able to innovate with generative design more than 8 years ago, and what are they doing today with generative AI? You will learn about all these topics and much more during our breakout session. My name is Alexandra Francois Saint-Cyr. My pronouns are she and her. I am the business development head for product engineering and development in the automotive and manufacturing business unit at AWS. So first, I will discuss the engineering and product engineering and development challenges that customers like you are sharing with us. Next, I will dive into how, at AWS, we embrace these challenges and tackle the ever-increasing complexity of manufactured products. The best way to experience what we do is to hear it directly from our customers. So Mauro and Giovanni from Ferrari, and then Heather from Autodesk, will give you insights on what they've been doing and building with AWS services on the cloud to better serve their customers. Let me now dive into the product engineering challenges. So the first one is about performance and scalability. Now, with the increased number of product features and the increase also of focus on higher quality, engineers need to have the ability to work on more complex, interconnected user cases. And in this case, they have to do really a combination of multiple disciplines, such as mechanical, electrical, thermal, and embedded systems. This challenge has led some of the mid-sized manufacturers to look at applying agile development, not only for software development, but also for physical product hardware development. Next on the list is data friction. We hear from you that you are experiencing a lack of data flow across all the business processes, regardless of the source format. Now, to get the most out of product development ecosystems, manufacturers need to be able to seamlessly interconnect multiple engineering platforms and applications so that they can link key activities such as requirement, design, analysis, verification, and validation. Finally, the last major challenge is global collaboration. So manufacturers are reporting to us that while their teams might be able to use a single source of the truth in digital format, well, what happens is that sometimes it's very difficult to extend this to any stakeholder, regardless of their location. So to tackle these challenges, manufacturers started using what we call model-based design and engineering approach, whereas before they would have been using a document-based approach. Now, typically, the starting point with this approach is a model such as a three-dimensional geometrical representation of the physical product, but that's typically defined using computer-aided design or CAD. That's a CAD model. Or you can also have simulation representations, commonly defined using computer-aided engineering or CAE applications. The ultimate goal of using these is to have models that are not only full depictions of the physical product, but that are also highly interconnected so that they mimic the performance of this product. And those typically are, you may have heard of these, are called as digital twins. But you also need to make sure that this data is also seamlessly interconnected, and therefore you're able to create a digital thread across the product lifecycle. Now, I have a question for you. Where are you on this journey? So do we have anyone in the audience that has a Model 2, which is where you have a level 2, which is where you have models that are being shared as part of the design deliverables? Anyone? Yes, great. Okay, that's great to hear. Thank you. Now I'm going to ask, do we have anyone that could build digital twins of their products yet? Much more challenging, right? Yes. So this is where at AWS we can help. So during the life cycle of a product, you see a manufacturer product going through multiple activities, starting with strategic planning and ending with recycling. The main activities that are related to product engineering and development are product planning, product design, and validation and simulation. Now, of course, these activities generate a lot of data, and that data needs to flow upstream and also needs to flow downstream to ensure traceability and so that a single source of truth for the product is generated. The data generated from production or even from service also needs to be able to move back upstream to the product engineering and development teams so that they can continuously improve the product. Now, that's why it is critical to build a closed-loop digital thread, and as Peter Bilello mentioned, he's the president and CEO of SimData. He mentioned recently in a webinar on product lifecycle management that cloud is the technical foundation for the digital thread. Now, diving deeper into the product engineering and the development activities, we identified 6 specific areas where AWS and our partners play a key role for our customers. For virtual design, we have a service such as NiceDCV, which provides a high-performance graphical user experience for remote desktops, while Research and Engineering Studio, a newly released product, provides a way to leverage multiple AWS services such as Amazon EFS and Amazon OpenSearch to help administrators in terms of managing and deploying a large fleet of virtual desktops instances while keeping a very close eye on the budget. When it comes to CAD and product data and lifecycle management, we work closely with partners such as Siemens, PTC, and Autodesk to ensure that their applications leverage AWS services to optimize their capabilities and continuously add new features that better serve their customers. Heather will have the pleasure to actually provide you with more insights on the different AWS services that Autodesk uses in order to create innovative software solutions. With regards to CAE and validation, AWS Parallel Cluster is an open source cluster management tool, and that allows to quickly deploy and manage high-performance computing clusters. You will hear from Giovanni. He will take a deeper dive into how Ferrari is leveraging this offering for faster virtual prototyping. We also recently released a product called TwinFlow, which allows you to build and deploy predictive models at scale. Now, we have additional key technologies that we are helping our customers with when it comes to product engineering and development. For instance, setting up a secure global collaboration so that models can be seamlessly shared, but also in a very confidential, protecting intellectual property. Using spatial review in order to leverage and democratize 3D and augmented reality fully, to get a full experience across the engineering and development processes. For example, as you want to do some collaborative design reviews. And applying AI and machine learning to capture knowledge in order to assist users, predict outcome, and also generate intellectual property. Now, obviously, AI, ML, and Gen AI have been on everybody's mind. I don't know how many times we've heard AI, the past few days, right? So what I like to do now is actually take a deeper dive with you to show you what we could do with those technologies when it comes to product engineering and development. So I don't know if any of you attended on Monday. We had a session on AI-powered manufacturing digital thread. Anyone attended this? Not sure? OK. So if you haven't, this was a session that really looked into how you could interrogate the product lifecycle of a specific product, and in this case, look into data associated with, let's say, a defect. You are specifically interested in looking at a defect. And then you could actually say, OK, I need to understand what supplier might be able to fix that defect, but I need to make sure that I know what kind of quality this supplier can also provide for me. And at the same time, you could also look into any of these supply chain areas, factors that you need to consider. So we do have that demo running at our booth in the AWS Industrials. So feel free, like tomorrow, I think at noon, we'll definitely have it. So feel free to stop by if you want to see it. Cadence, a leader in electronic systems design and AWS partner, recently mentioned that now the users of their applications can design printed circuit boards 5 times faster than before by using Gen AI and AI as part of their applications. You can also explore the new car designs and optimize the aerodynamic performance of this car using Gen AI and computational fluid dynamics. All of this just from a single car image. So these capabilities, you can see, create tremendous benefits for product engineering and development. For example, McKinsey estimated that the productivity will increase at a value of 10 to 15% of the research and development cost. You can also envision how this will impact the rate at which innovation happens, and how it will reduce the risk of recalls while increasing product quality. And finally, how it can enhance the way products are manufactured using new and sustainable materials. So now, Giovanni and Mauro will take over to share with you how AWS helps drive product innovation and enhance customer experience at Ferrari.
Thank you so much. Good afternoon. My name is Giovanni Longobardi, the Cloud Operation Manager for Ferrari Digital and Data Department. Before starting with content session, we would like to introduce you how we tell our story of passion, how we capture our constant desire to push boundaries. Let's have a look.
How do you tell the story of a passion? A passion born of the spirit of racing, carried in the hearts of enthusiasts everywhere. That defies time, age, language, and culture. That unites young and old, individuals and team, employees and owners in a lifelong sense of belonging. How do you capture the constant desire to push boundaries, master new technologies, adapt and evolve, to blend tradition and innovation, yet still stay true to your DNA? How do you capture the essence of what must be lived to be understood? For this is the essence of what it means to be Ferrari. To epitomize the power of lifelong passion, the beauty of limitless human achievement, creating timeless icons for a changing world.
We cannot describe passion. We can only live it. Fantastic. Our passion lives on emotions which transcend the road and track. It sets ambitious targets and expectations to match tradition with innovation. It is required to feed the ability to provide revolutionary technological solutions with exceptional artisanal craftsmanship, which allow us to create icons that stay timeless. Our talented people are our greatest resource, but they can pursue the extraordinary only by working together as a team. For this reason, we have founded some guiding principles, which will be introduced by Mauro.
Thank you, Giovanni. Hello, everyone. Nice to be here. My name is Mauro Coletto, and I'm leading the data science and business analytics team in Ferrari. So we have seen from the video, it was clear what's Ferrari. I think it's very well known, but Ferrari is racing, is sports car, and also lifestyle. And we are basing our strategy on technology and innovation, how we do that. So we are following some very relevant principles that are displayed in the slide. So the first point is continuous learning. So we all focus a lot on learn. So learn for all Ferrari people, it's very relevant. The concept that was introduced is confident humility. So by confident humility, we mean we know what we know, but also we are open to learn always more. So on this point, we are working a lot. So this is a world where things are changing very fast, and technology is changing and moving very fast. And we have seen the cloud transition and everything that is happening with the AI and generative AI. So it's very relevant to learn all this stuff, and that's a very important goal for the company. So we have been organizing different stuff within the company. One event that we do, it's for all the employees, and we call data-driven days. During these days, we teach to the people what is data, what's the value of data, how can you represent data, so data visualization, and also a little bit of machine learning. We also do some sessions for the business, which is very relevant, and we work with AWS for those sessions. And during those sessions with business owners, we tell them what's machine learning, how they can apply machine learning in their use cases. So this is very important also to bring new use cases within the company. We also have some technical session, of course, for data scientists. Data scientists are spread all over the company, and we do specific training on machine learning and AI. So that was the first value. So the very first value, we always learn, so continuously learn, which is very, very important in Ferrari. The second value is partnership. So we learn, we know a lot internally, but also we rely on partners and on their knowledge. So of course, we can mention AWS as a very, very relevant partner. Well, we have really a lot of partners with whom we work every day to improve our technology and innovation. Third value is collaboration. So by collaboration, I mean specifically internal collaboration. So what we have seen that data science and machine learning skills are spread all over the company. And that's common in big companies, medium and big companies. And so what we organize is what we call Data Science Hub. Data Science Hub is a meeting that we do regularly with all the employees, and the goal is to have the occasion to train the people to explain projects and to build a virtual community. So the community is not in the organizational chart, but the idea that we have data scientists spread in the racing part, in the Scuderia Ferrari. We have some of them in the research and development. We have some in the digital and data team. So the idea is to bring all of the people together and to work together, creating connections. We have been touching different topics in the recent sessions. So this is an example of the last topics that we touched. So what about these topics? So they have all in common data. So for those who were in the session, in the keynote this morning, data was the initial part, and that's the basic part for every journey, let's say. So data together with people and innovation is really crucial value for Ferrari and for product innovation. In product innovation, we really rely on data, and we have a data-driven approach. And in the last months, we have been working really hard in our department to rationalize our data sources and our data lakes. And we did that because we want to accelerate our move-to-cloud journey that we started already. So here you see our Ferrari federated platform. So this picture shows what's in Ferrari and all our platforms, but we will focus specifically on vehicle platforms. So in particular, we have developed two platforms. So one is vehicle data platforms, because vehicle data platform, and it is in AWS technology. And the second one is the connected car platform. So connected car platform is the platform where we have all the signals coming from the cars. And it's separate for the vehicle platform for security reasons. So we want to keep segregated the data for security reasons. We also have the vehicle data platform that I'm going to explain right now. So we'll focus on the vehicle data platform because it's a very, very good example how we can provide a lot of information to the engineering process. So as you see in the slide, the goal of the vehicle data platform is to collect data from different data sources. We have data sources that are legacy systems, Ferrari legacy systems. So for example, our diagnostic data, also all the data regarding the product life cycle, and also data coming from our content management system and enterprise relationship platform. So we have all of these data that are based on vehicles, all information regarding the vehicles, but also we have unstructured data. So for example, we have all the data coming from prototyping and testing. So all this data, they go into a platform, and the technology for this platform is DynamoDB. We also use AWS RDS APIs and also the S3 storage. So all the information go in the platform and how we serve this data. So we have two options. So first one is through APIs. So we developed standard APIs that to deliver the data to all our applications. And by application, I mean engineering process, but also all our digital channels, so websites, apps, and also social media, and all processing that are related to the vehicle within the company. We have also another stream of data, which is the reporting data and machine learning stream. So we use this data also as an input to machine learning models and AI, and I will describe in a little what is going on. And also we have a lot of reports and dashboarding. Okay, so I'll pass back to Giovanni that will get a little bit into what is computer-aided engineering process in Ferrari.
Thanks, Mauro. So now, what is KAI? KAI tools allow engineers to virtual simulate the product or component's response to load conditions in the operating environment, which means that teams can spend more time in the product development. However, leveraging KAI was not enough. Due to continuously increasing computational resource demand, other challenges had risen. Some of them. How can we improve our scalability for high-peak workload management? How can we reduce the computational solving time and enhance user experience? And how can we reach these achievements by keeping our TCO low as well? Here you can find which type of simulation are possible thanks to KAI. On the left side, you can find a typical sloshing simulation, which predicts the fluid motion inside a typical oil tank. On the right-hand side, you can find a typical gas engine exhaust simulation. So, Even if Kai gives us the opportunity to solve typical engineering problems like structural behavior prediction and fluid mechanics simulation, it was required to rethink another approach regarding how to deliver the computational resources to our engineering teams. And here the cloud comes into play. Let's see a typical application field for Kai, which is the high-performance computing, or HPC. Our HPC hybrid architecture in the AWS cloud leverages some cloud-native services. Let's see some of them. First of all, direct connect between AWS and Maranello for an high-speed performance network. Second, AWS Parallel Cluster, the core component of our hybrid architecture, with its compute nodes for calculations and the head node for orchestrating them. Third one, the RDBMS service in Amazon Aurora for keeping track of our job scheduling history. And finally, Amazon FS6 for Lastre for an high-performance NFS sharing, plus Amazon S3 for data tiering and keeping our storage costs low. But before proceeding with a productive scenario rollout, we have executed a huge benchmark test campaigns by comparing the computational solver time obtained by leveraging the hybrid architecture with ones obtained on on-premises only cluster. As you can see, each type of simulation has shown better results in terms of computational cycle time saving. Moreover, during last month, we have also introduced some optimization in our overall architecture. Let's see some of them. These benchmarks have been obtained basically by working and optimizing three principal components. First one, network. By enhancing our data transfer performance, we have improved the 75% of our use cases. End user experience. By introducing new UX technologies for simplifying pre- and post-processing models, we have improved the 91% of our use cases. And finally, scalability. Thanks to virtual unlimited resources provided by the cloud, we can avoid the on-premises cluster resources saturation, which means that we have improved the 100% of our use cases. These benchmarks encourage us to considering introducing a new type of experimentation, and we will investigate on this. In the meantime, let's see some machine learning use cases and other potential application field. Back to Mauro.
All right. So we have seen the data layer. So what is on the basis? We have seen our HPC technology. Let's move a little bit on the application layer. So we'll focus specifically on machine learning use cases, which are more interesting. So before going into the use cases, I will describe a little bit the architecture. So we'll focus on the vehicle data platform. That was the platform that I described, which is the input for all the use cases, all the machine learning use cases. We do use the SageMaker environment, and we also use all the off-the-shelf algorithm together with custom algorithms that we develop internally. So most of the use cases that we work on are about recommender systems, are about anomaly detection, are about computer vision, and forecasting regression. So we do have a lot of use cases, but I'll focus on a couple of them just to give you an idea of what we are doing with this infrastructure. So the first use case is about virtual sensing. So we use a lot of this. So that's an example for sports car, the department, business area. So we try to predict the value of some relevant metrics within the car, within the vehicle, starting from other additional metrics that we have. So for example, in this case, we want to predict the friction coefficient of the car, starting from a value that we have, like temperature, inner pad temperature, external pad temperature, speed, torque, and so on. So we developed a model, a custom model in this case, that was able to predict the value of the friction coefficient for the car, starting from all these values, and the prediction was very, very accurate. So by having this information, so by having the friction coefficient, we can improve the braking system based on the style, the driving style of the customer. Let's move on. So this is one of the general use cases. So we do a lot of this use case for different metrics. So we do a lot of sensoring, but also like I want to show this other use case. Sorry. Okay. So that's to complete the loop. So to show you how the information that are very relevant for the engineering part that can come also after the delivery of the car to the customers. So in this case, we see a computer vision use case, machine learning computer vision use case, where we try to auto-label pictures. And all these pictures can be pictures that we find online, so web content. And we developed a custom model, in this case, in SageMaker, using recognition and also custom label. And so starting with the identification of the object, of course, we can say if in a picture there is a car and if there is a Ferrari, and also we can say which is the specific model of Ferrari that is in the picture. So we can tell if it's a Ferrari Portofino, if it's a Ferrari Roma, and the accuracy is more than 95%. We can also say who are the people in the picture. So if the people are celebrities, we can, of course, recognize through the off-the-shelf algorithm, but also we custom train the model with pictures of relevant Ferrari people that are, for example, our chief officers. So in this way, we have a lot of information about content that we can find also externally. And of course, this is important for archive reasons, so in order to pick up content, to see what's the content that's outside, but this is our information that can go back also to the engineering part. Of course, we have some limitation on privacy and we follow the GDPR constraints, but if we can provide this information to the engineering part that again have the feedback from users, from customers on the real product, let's say. Last point I want to touch, of course, is generative AI. So all the conference is about generative AI, so we know that is a big potential. And of course, also in Ferrari, we are testing and experimenting a lot with generative AI. So what's generative AI and why is it so important? It changes a lot the speed that needs for, it's important for engineering, for process engineering. So usually when we have to design a part, we go through a lot of runs, a lot of cycles that can be weeks to design a component, a specific component. With generative AI, we have the possibility to have a lot of different variations of the same component that can be after judged, evaluated by the engineers, by the designer, and can be selected for prototyping. So that's a really very important game changer, and we are working a lot also on that. So I will now leave the floor to Heather. She will go even deeper on the generative AI part from Autodesk.
Thank you. Thanks, Mauro. So, hello, I'm Heather Carrick, and I'm going to talk to you about how Autodesk and AWS are working together to help wrangle some of the complexity in the manufacturing industry that Alex talked about. And yes, I will be talking about generative AI. So by show of hands, how many of you have heard of Autodesk? Oh, okay, good, great. We got a lot of fans in the room. So for those of you who didn't raise your hand, Autodesk makes software that helps people design and build really everything around you. We span multiple industries: architecture, engineering, and construction, product design and manufacturing, which is my department, and media and entertainment. So if you think about the plane you flew to get here, the movie you watched on that plane, the car you rode in to get here, the building we're in, and the chair you're sitting on, all of those were likely designed with Autodesk somewhere in their workflows. And just for some stats, Autodesk is about 40 years old. We have 13,000 employees globally and over 6 million subscribers to our tools. And those tools create chairs and planes and buildings that impact billions of people around the world. And underpinning all of that is AWS. We need a connected technology stack to connect things like design and compute to create workflows that flow within and across all of these industries. A prime example of this is with Autodesk Fusion. Fusion connects all of your tools in the manufacturing space. So design, simulation, documentation, manufacturing, electronics, rendering, you name it, all in one platform. We started Fusion because we saw that you needed a single environment for design and make workflows, a place where data can move easily for different kinds of teams and people to work together across different systems and locations. And partnering with AWS, we've been able to optimize how we leverage the cloud so that we can offer this tool with really sophisticated workflows at an accessible price. So throughout the session, we've talked about some of the complexity and the challenges that the product lifecycle is facing. And this diagram is really the one that Autodesk is working on. So you see there's all sorts of people and all sorts of softwares and vendors and systems and file types. Anyone see themselves on this diagram by any chance? Person up at the top, person down the corner. This is how manufacturing works today, and it's kind of bananas, frankly. And we think, at Autodesk, we think that your software tools, your design tools should really help smooth all of this out, make this easier to understand, especially because there are a ton of external challenges facing manufacturing. There's a labor shortage, there are supply chain challenges, there's an increasing need for sustainability. And what often happens is the person way off in the top left corner makes a change, not realizing that it totally breaks what the person down in the bottom right corner is doing. There's all sorts of multiple variables and different ways that they interplay, and it's really hard to understand the impact of all of those things. And so we are using tools like Autodesk AI tools to really help wrangle that complexity. So we have Autodesk AI tools in Fusion and in our other software across the Autodesk Design Make platform. So we're a software company. In order to create these AI-powered tools, we require a lot from our technology stack. And it's the kind of things that we get from AWS. We need high performance. We need high performance compute in order to do a lot of this computation. You, our customers, trust us with your business. 6 million people trust us with their business. We have to keep your data secure, and we have to offer our services to you reliably. And as we're seeing very acutely this year, technology is changing all the time. And so we need to be flexible and scalable to absorb new innovations and scale to greater sizes and further scope. So one example of how Autodesk and AWS have partnered in this way is with generative design. So we started generative design about 8 years ago in 2015 when we partnered with Airbus on this bionic partition. So I'm going to clarify my terms a little bit. I work with scientists and researchers every day, and it's really easy to get hung up on semantics. But I just want to clarify this generative design is different than the generative AI that got super popular this year. Both are generative, as the name implies, so they create new content. But generative AI is based on machine learning. You train machine learning models, you show bajillions of examples, train models that learn patterns. Those models, based on what they've learned, will create new content. One thing about generative AI, especially right now, is it's kind of a black box. It's hard to always know how you got a particular outcome. And people have probably heard of hallucinations. It's possible that the suggestion offered by your generative AI model might look kind of cool, but may actually be false in some way. And in the manufacturing industry, that's kind of a challenge. So generative design, by contrast, uses equations. So it's all deterministic. There are simulation equations and physics equations. And so as a user, you describe what you need your part to do. What material is it made out of? What weight does it need to bear? And then under the hood, a bunch of different equations get crunched, and multiple totally valid, mathematically accurate solutions are computed and offered to you. And because we know all the equations, we can see the impact of different variables. And so what it offers to you is the ability to understand those trade-offs, to see what happens if you try to do this faster, what does that do to cost? If you try to make it lighter, what does it do to strength? And so you can actually see the interplay of those variables. So one example of this is General Motors used generative design and additive manufacturing to design and build a functional and lightweight seat bracket. Their goal was to optimize for weight, or mass, technically. So in the past, human designers would have made 2, maybe 3 designs for this challenge. But those human designers partnered with our software, made 150 viable options. We actually had to train a machine learning model to group these options to make it possible for users to navigate these choices. Ultimately, they designed a seat bracket that was 40% lighter, 20% stronger, and consolidated 8 different parts down to 1. Part consolidation really is helpful for the assembly process, and making a part lighter and stronger is obviously better for the life cycle of that vehicle. So AWS was essential to this tool. In order to compute and generate hundreds of designs and display them in a way that someone could explore that design space required a really sophisticated backend. So we worked with AWS and we created a backend with parallel compute that uses both GPU and CPU. It would not have been possible to make generative design without AWS's tools. So that was back in 2015. So over the years, we've kept expanding generative design. So with the fact that we have all these AWS components, we can kind of mix and match and recompose new workflows using some of our old tech and adding in new technology. And that's how we expanded generative design to include things like generative fluids and automated modeling. So generative design is great for structural components, but I mentioned it's simulation-based, and has anyone used a simulation tool? Anyone know? Okay, I see some hands. You can tell your peers. It can be a bit of a challenging environment for people. It's a really different kind of user interface than a design space. And what we found was that not everyone found generative design for structural components as accessible. And so we created the automated modeling tool to put generative design in a design space which is more comfortable for some users. Also, over the years, we've expanded generative design to cover multiple manufacturing methods. So the GM example used additive manufacturing. But additive manufacturing is not really the best manufacturing method or appropriate for all use cases. So we needed to add additional equations and additional capabilities to generative design to be able to offer manufacturing methods that were relevant to all of our different use cases. So now generative design shoves those more equations in, and it can support additive, die casting, 3- and 5-axis milling, 2.5-axis milling, and 2-axis cutting. And because we have all those equations, we can really help users understand how their choice of manufacturing method impacts their decisions. So MJK Performance creates parts for performance motorcycles. They use generative design to design a triple clamp. And so there are 3 designs that they compared to the human design in the center. So you might be able to see, depending on the text, the additive design was by far the lightest. But based on their production volume, way too expensive. So the 2.5-axis design was 23% lighter and worked with their production volume. It was a more manageable cost. And so using generative design, they were able to go from an idea to a computer model to a physical prototype in their hands in a matter of hours. As I said before, the underlying building blocks of generative design use AWS. And so we can componentize them and mix and match. We do A/B testing, add new stuff, and it lets us continuously improve this tool without disrupting any existing user. So in our most recent update, we improved our structural design solver. Mauro and Giovanni talked about solve times as well. Like it's really important to be able to be as fast and efficient as possible with this. We now support those 6 manufacturing methods, and we've done a lot of work to increase the robustness and resiliency of our solver. And so in order to offer flexible business models, we have to use our computing resources really effectively. So we use AWS for a mix of GPUs and CPUs. We use batch and step functions, and we use spot instances to use exactly the right amount of compute at the right time so that no resources are wasted. So that's how we use AWS to really handle the multivariable aspect of this problem. But another part of this problem is all of those red arrows. Engineers spend 30% of their time in these red arrows. They're doing non-value added tasks, tedious work, transcribing really data from one format to another. And they tell us nobody wants to spend their time that way. People would much rather spend their time on the really interesting, creative, challenging problems, not reformatting something, telling one computer how to talk to another computer. So drawings is a great example of this. Manufacturing drawings are super important. Basically, every manufactured part needs one. It's critical to ensure that that part is created as it needs to be, that it has all the right dimensions in the critical places. But these are really tedious to make. They can take hours to make. And all they are really doing is illustrating information that's already in the 3D model. And so it requires a bunch of time and a particular domain expertise, but it's not particularly creative. And folks that do it would love to do it faster. And so now users can request automated drawings. So this is coming out in the next build of Fusion. You take your assembly, click a button, that assembly gets sent to the cloud with AWS technology. It gets churned, and then you get notified when your drawing is ready. So in this case, this person now has 24 sheets automatically made. Part of what makes drawings really hard to automate is that there's no one right way to do it. It's sort of half art, half science. Depending on your manufacturing method, your company's standards, you may need the drawing to be set up in a different way. So we offer people a menu, sort of a number of recipes. So you get to control how your drawing ultimately looks. The dimensions get placed on the sheet. Everything is fully parametric and editable, so you can still make your finishing touches, move a dimension here, add one there, bada bing, bada boom. But now we've saved hundreds of hours of time. So this drawing is fully editable, and we're really excited about what this means to free up everybody's time to do more interesting problems. So generative design and automated drawings help superpower our customers to achieve their goals faster. And both of them, as I described, use sort of rules and equations and heuristics under the hood. But there are some problems that we really can't solve that way. And so that's where machine learning comes into play. We are leveraging machine learning to develop more AI-powered tools for those challenges. And we need dedicated tools as a software company in order to do that. So over the last few years, we created the Autodesk machine learning platform for all of our internal machine learning teams to access the tools that they need. The platform is built on top of AWS, and it uses Amazon SageMaker, batch, step functions, and other AWS components to optimize how we use our resources. As we scale our machine learning footprint, it becomes essential to manage things like compute and data storage effectively. The platform has different tools to support different part of the machine learning lifecycle, but it kind of chunks out to things around obtaining and managing your data, training models, deploying models, and then monitoring how they do in a production environment. With this platform, it's easier for all software developers to work with machine learning models effectively. So for non-experts in machine learning, who are standard software developers, it makes the off-the-shelf models easier to access. So folks can grab these models and plug them into their workflows really effectively and quickly. And it enables the machine learning researchers to access increasingly powerful compute to develop and train new models, create data sets, and do things like training on data without copying or moving it. When you have really large data sets, that kind of thing is really important. And also with data governance, ensuring that that data stays in a safe place. And this platform lets us apply these governance rules to ensure that we can control who has access to what data and where that data lives. For the past 5 years, the Autodesk AI Lab has been advancing the state of the art for AI and machine learning in 2D and 3D geometry. The lab has published over 60 papers and several data sets for the larger academic community. 3D data is a lot harder to obtain than things like text and images. You can't really scrape the internet and get a useful, meaningful data set of this kind of data. And that's been a real challenge for the research community and academia to really get off the ground in the same way that has been possible for data like images and text. But luckily, Fusion has an amazing and passionate user community. Over the years, many designers and engineers have published their designs to a tool called the Fusion Gallery. And so a few years ago, our AI lab was able to pull designs off of that gallery, curate it a bit, and create the first data set of its kind that had really, really rich data about how CAD models are made and what was going on in that data. And we published the Fusion Gallery data set, and we've added a few more additions to that data set and shared it with the academic community. And it's really been great for helping expedite innovation in this domain. So building on the work of the AI Lab, we are exploring applications of generative AI and how it can further help us tackle the challenges in the manufacturing industry. One of the areas that we're really looking at right now is how to get a design out of a designer's head and into a computer. For example, Autodesk Research partnered with Kia to build a generative AI tool for concept generation for wheel designs. They used AWS to generate the data that they needed and created a model that understood these intangible concepts like dynamic and photos, and could also understand design principles like symmetry. The tool enables Kia designers to quickly generate and modify their wheel designs and then ultimately create a 3D model. Going further in the automotive space, kind of the theme of the day, Autodesk recently acquired Blank AI. This tool allows any automotive designer to encode their brand's specific design DNA and then generate and tweak 3D designs that still kind of had the essence of that particular automotive brand. The designer can make adjustments using semantic controls, again, dynamic, unique, bold, and immediately visualize the outcome in a rendering environment. So we're hard at work onboarding this new capability onto the AWS platform and using AWS to help scale it to more users. So we'll keep working with AWS to continuously improve and expand these workflows. So I'm really excited to see how folks like you can use Autodesk AI today and the new tools that we will continue to share with you. I'm going to pass it back to Alex to bring us home.
Thank you, Heather. So thank you very much. I hope that what Mauro, Giovanni, and Heather shared with you today made you better understand the value that AWS Cloud can bring to product engineering and development. Mauro and Giovanni described how Ferrari is able to increase the innovation and collaboration with the customers and suppliers via their digital platform and also by leveraging high-performance computing. Heather showed us how Autodesk helps their customers not only reduce time to market, but also how they can shrink the number of design iterations they do through that cross-functional collaboration and by leveraging AI. Now, just visualize how you could design an aerodynamically improved car from just an image by using generative AI and also by using machine learning, and how your team could potentially look at that design and experience the styling of this design of the new car via a collaborative augmented reality visualization. So there'll be more to come on that topic early next year, so stay tuned. So thank you very much for attending our session today. Mauro, Giovanni, and Heather and I really hope that you enjoyed the session and that you were able to learn something that meet and that you might be able to use in your day-to-day life as a designer, an IT person, or on that. So as you know, we are data-driven at AWS. So as such, your opinion greatly matters to us in order to make sure that we always improve our efforts in providing you the best content. So please take a moment to fill out the short survey that we have on the mobile app, and so that we can really hear from you and make sure that we always satisfy what you're looking for in terms of our delivery content. Thank you so much.
Thank you.